presenter over here. My name is Anushka Sahu. Yesterday, I have started the playlist of data science covering the basic and advanced concepts. Now, today I am going to discuss the next topic, that is exploratory data analysis. Now, let's discuss what is EDA. EDA is a crucial and critical first step in a data science process. It involves analyzing and visualizing data sets to summarize their key characteristics, uncover patterns, identify anomalies, test hypotheses, and check assumptions. EDA helps you to better understand the data you are working with and guides the next steps in modeling or hypothesis testing. Now, why we use EDA? What is the importance of it? Now, let's discuss one by one. First is understand the data. EDA helps to build an intuition about how the data behaves, its properties and structure. Second, it improves model accuracy. By identifying key patterns and relationships, EDA can inform feature engineering and data preprocessing steps. Third is it guides hypothesis testing. It helps formulate hypotheses about how variables interact before moving to more advanced analysis or machine learning models. Fourth, data quality. It allows you to spot errors, missing values, or inconsistencies in data early on, which is crucial for ensuring robust analysis. Now let's discuss what are the tools and libraries which we use for EDA in Python. First is pandas, used for data manipulation and cleaning. Second is matplotlib for creating a wide range of static visualization. Third is plotly for interactive visualizations. Fourth is numpy for numerical operations. And fifth is scipy for statistical functions or tests. Last but not the least, stat models for advanced statistical modeling and hypothesis testing. Now let's discuss what is bar graph and how to construct bar graph with overlay in Python. In Python, the most common library for plotting is matplotlib, though Seaborn provides a higher level interface for creating visually appealing plots. Now let's discuss how to construct a contingency table in Python. In Python, you can use pandas library to construct a contingency table using the pt.crossType function. This function is highly flexible and can take multiple categorical variables to build a cross tabulation. Now let's discuss how to construct overlaid histogram in Python. Before discussing the construction, let's discuss what is histogram. Histograms are a great way to visualize the distribution of a single numerical variable, and sometimes you might want to overlay multiple histograms to compare the distribution of different groups or datasets. Now constructing overlaid histogram in Python. In Python, you can use matplotlib to overlay histograms. You can control transparency with the help of alpha parameter and adjust the bin width using this bin parameter. Now, what is binning and how to perform binning in Python? Binning or discretization is the process of converting continuous variables into categorical values of variables by dividing the range of data into discrete intervals or bins. This can be used for predictive modeling, especially when you want to capture nonlinear relationships or reduce the noise in the data. Now, how to perform binning? Binning based on predictive value. In Python, we can use pandas, numpy, or machine learning algorithms like decision trees to perform binning. Other binning strategies are k-mean binning. You can also apply k-mean clustering to divide the contiguous variables into clusters that are predictive of the target variable. For example, you can use k-mean from scikit-learn or k-means from R. Now, after discussing the theoretical part, let's move on the practical part. Now let's discuss and let's see how to construct a bar graph with overlay using Python. In order to do this, we will first import matplotlib module as alias name PLT. We can also import numpy module as alias name NP. Here the sample data which I have used is categories in the form of list, values 1 in the form of list, and values 2 in the form of list. In order to construct bar graph, we first need to calculate the width of each bar. And in order to calculate or construct a bar graph on x-axis, we have to use the index variable in which we are storing length of categories using np.arrange function. In order to create bar graphs, we have to use function that is plt.bar. In this function, we have provided parameters like index values 1 bar with label. In order to add labels, titles, and legend, we have used functions plt.xlabel, ylabel, title, xtext, legend. In order to display the plot, we have to use a function that is plt.titleLayout and plt.show. Now second, let's discuss how to construct contingency table using Python. First, we have to import pandas library using alias name pd, and I have used sample data in the form of dictionary. And in order to display the data in the form of data frame, I have used pd.dataframe putting or displaying data. Now in order to create contingency table, we have to use a function known as pd.pivot table, in which we are providing variables like df, values, index, columns, argument function, etc. Now third, let's discuss how to construct histograms with overlay using Python. First, we have to import matplotlib library. Second, we have to import numpy library. Third, we have to import pandas. In this, I have also used data in the form of dictionary. Next, in order to show data, I have used pd.dataframe dataset. In order to group data, I have used group by function and storing the result in grouped variable. In order to create histogram, I have used a function known as grouped.plot. In this, we are providing perimeter equals to kind equals to bar, fig size equals to 8,6. At last, in order to customize the plot, I have used x label, xy label, title, xtext, legend, tight layout, show, etc. Now, last but not the least, how to discuss how to perform binning based on predictive values using Python. First, we will import pandas module with alias name pd. We will import numpy module with alias name mp. And then we will use the function bin by predictive values, in which we will provide the parameters like df target column, feature column, and bins equals to 5. And in order to calculate the predictive value for the feature of each quantile, we will use the statement df quantile equals to pd qcut function. In this, in order to create a mapping from quantiles to bin based on predictive values, we will use a bin mapping, in which we will store empty dictionary, and then we will use sorted methods, enumerate methods. In order to assign bins to the data points based on mapping, we will use df bin plus feature column df quantile dot map method. In order to drop the temporary quantile column, we will use df dot drop function. At last, we will return the df. So this was all about the practical part of XPT data analysis. Thank you for listening me patiently. Have a nice day ahead.